Okay. Today we will solving numericals on refrigeration. Okay. These numericals are refrigeration. So as we discussed in the previous class, dear students, in the refrigeration, the first step. So what we do is we'll understand the first steps, how to identify and how to solve the given numerical in simple way. First point, what we need to do is you have to identify whether the given numerical is VCR or VAR. There are only two types of numericals will be given in these your exams or in the curriculum. One is VCR. What happened to this? VCR type and VAR type. And VAR. What is VCR stands for? Vapor Compression Refrigeration, and VAR is Vapor Absorption Refrigeration. So the given numerical either it belongs to VCR or VAR. How to identify whether which category it is? First point we need to what you can means highlight or to search the word is compressor. If any word in the given numerical, the statement, if there is a compressor is there, compressor word is given, then it is VCR. If in place of compressor, another word will be given, absorber. Okay, or some data related to pump. If you use the word pump or absorber, it is related to VAR. That is the first step you need to define. The second step, what you need to remember here is, assume that VCR is given. We are solving numerical on VCR. So most of the numericals in the question paper will be asked based on VCR. So what is the next step we need to do in the VCR is identify type of refrigerant, whether it is freon, ammonia, air, whatever. Okay, type of refrigerant. So why it is important step is because we need to take the properties from the thermodynamic data handbook. Until and unless you not identified the type of refrigerant, we cannot refer data handbook. So identification of type of refrigerant is important. For example, ammonia NH3, air, freon 12, freon 22, like that. Next step, the third step, what we need to do is inlet condition or inlet to compressor. Inlet to the compressor or outlet of compressor. What is the keyword of point number 3 is condition. You have to identify which condition is given, whether inlet to the compressor is given or outlet of compressor is given. Any one will be given in the numerical. He will use the word specifically inlet or he use outlet. That is the third step. Next, once you understand these 3 points, the next point is you need to draw PV and TS diagram. So PV is not necessary here. Draw TS and HS diagram. Fourth step is TS and HS diagram. So most important is TS. Fifth step, what we need to do is, once you draw the TS, note down the values of the refrigerant from the thermodynamic data handbook. Note down the values from the thermodynamic data handbook for the given refrigerant. And one of the video lectures, we have explained you how to take the values from the data handbook. Okay, point number 6, write down the formulas. Formulas, substitute the values and get the answer using values from step number 5. Whatever the values you will note down in the step number 5, all those values you have to write. Understood? Okay. So what is the first step? First, identify whether it is VCR or VAR. So today we are going to solve VCR problem. So in the VCR, the second step is type of refrigerant you need to identify. Once you identify the type of refrigerant, the immediate step you need to do condition. So 90% he will give the condition with respect to compressor, because based on compressor and absorber, we are differentiating VCR and VAR. So 90% data will be given with respect to compressor, either inlet or outlet. I will explain you how to take the values if it is inlet, in outlet, what is the condition. Once you identify the condition, type, and the VCR, then draw simple TS and HS sketch. You need to draw one simple sketch. Then note down the values from the thermodynamic data handbook. Okay. Next, formulas, and substitute the answer. We'll get the substitute the values. We'll get the answers. Okay. We'll take one statement. Before taking the statement, let me explain you the point number 3. What is inlet? What is outlet? So that the numerical will become easy for you. Okay, dear students, first you observe the third diagram. This is diagram A, this is B, this is C. Okay, so third diagram is a TS diagram. Third diagram is TS diagram. In the TS diagram, as I told you, there will be 4 processes in the VCR. Remember, there are 4 processes. VCR working principle, I think, for example, device is a refrigerator. That what is called fridge. Okay, fridge or what refrigerator, what we are using in our house. That refrigerator works on the principle of VCR and Bell-Coleman cycle. In the refrigerator, it undergoes 4 processes. First, 1 to 2 is compressor process. For this diagram, for this sketch, I am explaining. Notations will be different. Okay, don't take it always 1 to 2 is compressor. They may change to 3 to 4. They may change to 4 to 5. Notations will be different. Okay, here I am considering 1 to 2 is compressor process. 2 to 3, it is important. 2 to 3 is condenser process. So in the condenser, heat rejected outside from the cycle to the surrounding, heat rejected. And in the 1 to 2 compressor, work is done on the system. So most of the time in the question paper, he will ask you what is the work supplied to the compressor. So it is also important data. 3 to 4 is expansion. What type of expansion? It is a throttling process. Throttling expansion. And 4 to 1 is evaporator. Evaporator means evaporator is heat is added to the cycle. In the evaporator, refrigerant absorbs heat from the room or the space to be cooled. Okay. Dear students, I will give some hint how to remember this one. 4 to 1 process is also called refrigerating effect. This word is important to solve numericals. In the numericals, they will not use the word evaporator. Instead of evaporator, they will use the word refrigerating effect. Keep in mind, refrigerating effect is related to evaporator. Okay. In the second point, what second hint is throttling process, the enthalpy, that is 3 to 4 is throttling process. From this point to this point, it is a throttling process. Okay, someone is requesting me to enter into the class. Let me admit him. Okay, fine. 3 to 4 is throttling process. Remember, my dear students, for throttling, enthalpy at point number 3 is equal to point number 4. H3 is equal to H4. Do not waste your time in calculating H3, because to calculate H4, you need minimum 5 to 6 minutes of time and you have to scratch your head. So H3 will be getting directly from the data handbook. I will tell you how to take the value of H3. So do not waste your time in calculating H4. Calculate H3 or note down the values from the thermodynamic handbook directly and equate it to H4. So that is a hint. Okay. 2 to 3 is condenser. Okay. Observe this point carefully here. Point number 2 is outside this curve. So this curve is vapor line. This line is vapor line. This line is saturated liquid line, or they can also call saturated vapor line. Saturated vapor line. This right side curve. Left side is saturated liquid line. So point number 2 is outside the saturated vapor line. So it is in superheated condition because it is all away from the vapor line. Already it has crossed. If you are viewing from this point, from the side view, this point is already it is crossed from the vapor line. So it is superheated. So point number 1 is on the vapor line. So it is called dry line, dry point or saturated point. Very important point you need to remember to solve numericals. Okay. So I will give an example. In the question paper, you will say that the condition of the refrigerant at inlet of the compressor is dry and outlet of the compressor it is superheated, then this diagram satisfied. You have to use this diagram to calculate values, unknown values. But instead of saying the condition of the refrigerant at inlet to the compressor is dry, he will say that a refrigerant at inlet to the compressor is wet. Then this diagram will come into the picture. Just look at the point number 1. Point number 1 is not on liquid line. Point number 1 is also not line, vapor line. So it is in between these two. So it is wet. Point number 1 is always, remember, it is inlet to the compressor. I have already written here, compressor. Point number 2 is on the vapor line. So this will become dry line in this case. This is dry line, dry point. Point number 2, in the first diagram, A sketch, it is dry point. But in the C diagram, point number 2 is here. Point number 2, where is point number 2? Point number 2 is here. So point number 2 is here, means it is superheated. Point number 1 is dry line. But in the first sketch, point number 1 is in wet condition. Point number 2 is in dry condition. 90% of the numericals you will give these two conditions. Anyone, not two, anyone. Either he will specify point number 1 condition or else point number 2. Will not mention both. If they mention both, there is no question of getting confusion. Okay, shall we take the numerical now? And we will take the numerical, we will apply all these 4 steps and we will solve one simple numerical. Okay, I will take on your numerical from the previous question paper, university question paper. Okay, time parallelly I will be writing the solution. 1 minute of time. Okay, have understood the process. If you have any doubt, you can ask me. If you have any doubts, you can ask me, my dear students. Otherwise, you will get confused. Is there any doubt in identifying the condition of the refrigerant? Do not have any doubts, we will move further in the next step. Please respond.
No doubt, sir.
Thank you so much. Okay, fine. Okay. Next, solution. First point, read the statement. A ton ammonia, a 10 ton, okay, there is a spelling mistake, you write 10. A 10 ton of ammonia ice plant operates between evaporator temperature minus 15 degrees Celsius. So evaporator is given, this is one component, and temperature is given. Write down here, temperature of the evaporator Notations will change. You will take different notation later. Minus 15 degrees Celsius and convert it to Kelvin. So if you have calculator, please tell me how much value it will be. Minus 15 plus 273. How much it will be answer? Minus 15 plus 273. Do not wait for my answers. Please respond me so that I can write fast.
258, sir.
Very good. 258 Kelvin. Okay. Next point. And a condenser. Second point is condenser. Condenser temperature is 35 degrees Celsius. So right here, temperature of the condenser is equal to 35 degrees Celsius. Write down the and convert into Kelvin. How much it will be?
308.
308 Kelvin. And dear students, here condenser is given, evaporator is given. Out of these two, which one is a refrigerating effect temperature? Which is refrigerating effect temperature? 258 or 308? I given one hint. Refrigerating effect is related to which component of the refrigerator?
Evaporator.
Evaporator? Very good. It is related to evaporator. That is what I showed here. No? Somewhere here. Yes. Here I have told you. I will highlight. This is the refrigerating effect is related to evaporator. So refrigerating effect temperature is given. Okay. So here to avoid the confusion, I will write refrigerating effect data. What data is related to refrigerating effect? Next line. The ammonia enters the compressor as dry. So which diagram will you prefer? Which sketch will you prefer? Dry saturated vapor. Clearly has mentioned. Enters means at the inlet. Enters the compressor as dry saturated vapor. So out of three sketches, which sketch will you prefer from this? For the given numerical? Inlet to the compressor is dry. Will you prefer the sketch 1 or sketch C?
Sketch C.
Sketch C, correct. Because 1 to 2 is compression process. Point number 1 is inlet to the compressor. And point number 2 is outlet of the compressor. So point number 1 is on vapor line. So it is a dry line. Dry line. So if the condition is inlet to the compressor is wet, then this diagram will come into the picture. Inlet to the compressor is wet, this diagram will come. Okay, very good. So I will write inlet to the compressor is dry. Let me write in words. Inlet to compressor is dry. Next line, what is given? Okay, let me show you the screen. Next line. And isentropic compression. Okay, I will explain you once solving the numericals. I told you. Entropy remains constant. Simple word is compressor is undergoing isentropic compression. So determine mass flow rate. First point, we have to determine mass flow rate. Second point, if ammonia, okay, mass flow rate of ammonia, it is of ammonia. So this is the first point you have to do. Type of refrigerant. So ammonia is given. I will write here NH3 ammonia. This is also important because we need to take the values from the thermodynamic data handbook. Until unless you identify what type of refrigerant is given, we cannot take values. Ammonia. Second one, COP, he has asked. COP of the plant. Third point is power input. Power input. So first, what is the step we have done? Yes, it is related to VCR or VAR.
VCR.
VCR. Why it is VCR? Why not VAR?
Compressor is given.
Yes, compressor is given. So we have identified. Very good. So what is the next second step? Type of refrigerant. Have you identified the type of refrigerant? Which one is given? Which is the type
Ammonia.
of refrigerant? Yes, ammonia. So second step also we have given. Very good. Correct. step and step is correct. Next, third step, what you need to do? Condition, that is condition. The keyword for the step name is 3, condition. Inlet to compressor, it is given. Any one will be given, inlet to compressor or outlet of compressor. So inlet to compressor is dry. Inlet to compressor is dry means you have to draw the simple TS diagram. I will draw it here. So inlet to the compressor is dry means 100% outlet will be in superheated condition. Keep in mind. If inlet is dry, 100% outlet of the compressor will be superheated. So this is saturated liquid line, saturated vapor line, and take the values of point number 1. Point number 1 is inlet to the compressor. This is dry condition. So I have taken on the dry line. If it is in wet, I could have taken between these two somewhere. If it is superheated, I could have taken here. So point number 1, draw one vertical line. Why we need to draw vertical line? Because clearly he has given isentropic compression. Isentropic compression here is given. In the isentropic compression, entropy remains constant. So S is entropy. So we have to draw one vertical line. Draw one vertical line. Keep in mind why I am drawing vertical line, because it is a isentropic process. So entropy is constant. So 1 to 2. So point number 2 is in dry line or superheated condition. Tell me anybody. Point number 2
Superheated condition.
is in superheated or it is in dry in this diagram, in this sketch. Superheated.
Superheated,
Correct.
sir.
Blindly you, okay, keep in mind, blindly you draw the circle, draw the sketch. If the point number 1 is dry, 100%, blindly you draw point number 2 is in superheated region. Do not think anything. Next, to complete this cycle. Like this, you have to draw. Okay, and it is refrigeration means anti-clockwise. If it is vapor, IC engine cycle means it is clockwise direction. Here it is anti-clockwise. I will take this point as 3, this point as 4, this point as 5 for our unconditional. You can take A, B, C, D, F, G, no problem. So in this diagram, I need to calculate enthalpies at each and every point. Okay, this is step. Fourth step. Next point. Next step, what we need to do? What are the next step is here? Note down the values from the thermodynamic data handbook. Now we will write down the values at point 1, at point 2, at point 3, all the values. Okay. So point number 1, H1. Okay. H1, H2, H3. So before that, I will write something. 5 to 1 is refrigerating effect. How much temperature he has given for the refrigerating effect? It is minus 15 degree Celsius. 2 to 4 is condenser. How much temperature is given for the condenser? 35 degree Celsius. Okay. Next point. Okay, dear students, 4 to, what is the name of the 4 to 5 process? 1 to 2 is compressor, work is done on the system. 2 to 3 is condenser, the condenser. 5 to 1 is evaporator. What is 4 to 5?
Throttling.
Expansion.
What is 4 to 5?
Throttling.
Throttling. Throttling. What is the condition for throttling process? H4 is equal to H5. For throttling process, you remember this one. Because many students will be wasting their time in the exam to calculate the value of enthalpy at point number 5. So this is a very hint and important point. You remember always for 4 to 5 is throttling process. So during throttling, enthalpy remains constant. So blindly you write H4 is equal to H5. Calculate H5 is difficult compared to H4. H4 I will get directly from the thermodynamic data handbook. Now, dear students, what you need to do, please take a thermodynamic data handbook and note down the values at minus 15 and 35 degrees Celsius. So what you need to write, please open the thermodynamic data handbook, minus 15 degrees Celsius and 35 degrees Celsius. First, identify what is the type of refrigerant he has given, ammonia. Go to ammonia table. If you have thermodynamic data handbook, please open thermodynamic data handbook. Thermal properties of saturated ammonia. On page number, please respond. Otherwise, no use of solving numericals. Page number, how much?
26.
Already you have thermodynamic data handbook. 40.
26.
Page number 26 is related to saturated ammonia. Saturated ammonia. What is the condition he has given for in your diagram? Superheated or saturated? What is the inlet to the compressor? Or what is the outlet of the compressor? Okay, at least okay. You go to page number 26. Okay, as you said, you go to page number 26. We'll see. Page number 20. Okay, tell me the value of HF. I hope everybody is following the same steps. Otherwise, you will not understand this numerical. Page number 26. How much is the temperature he has given? Minus 15. So at minus 15 is the direct value it is given minus 15 in the thermodynamic data handbook? No. Minus 14 is available. Minus 16 is available. Okay. Minus 15 he has not given. You can take the average of 14 and 16 and you will get minus 15. Please help someone and help me to write the values of HF at minus 15. Ready, sir? Okay, I will write here. HF at minus 14 degrees Celsius. How much he has given? Yeah, minus 14, how much? 116.
Average is 112.35.
Okay, very good. Okay, 16, 107. 107.8. The average, how much you'll get? Please repeat it once again.
112.35.
112.35 is a value of HF. Still, I am not writing H1, H2, H3. Just I am note down the value from the thermodynamic data handbook. Out of this table, some values I need, so I will take later in substituting the formula. And tell me HFG from the same 15 minus 15 degrees Celsius. Tell me HFG. Take the average at minus 14 and minus 16. Take the average and write down the value of HFG. Other students, please help me to write this table. 13.
13.25.
13.25. Okay. Next, HG. HG. Some other students, you try for 35 degrees Celsius. For the same table, ammonia table, write down the value of HF, HFG for 35 degrees Celsius so that we can write and can solve the problem.
1425.7.
1425.7. Similarly, SF. Is it 35 degrees Celsius column available or we need to take again average? No, again you have to take average. 34 is given. Is it 35 is given? No, 34. 34, 36 is there. There is a printing mistake. 32, 34, 33 printed. It has to be 36. Okay, so you need to take at 35. Please help me to write the value of SF.
0.0.
0.45.
685.
6 sakama. 3 digits. Next, SFG. So even I will also calculate for something. For minus
0.456.
Which value, ma'am?
SFG.
SFG is how much? 0.
No, sir, 1 second.
Yeah, SF will not get 0 because correct
5.0884.
5.088. SG. Again, you will get in the range of 5 point something. 5 point. Let me do in the calculator. Minus 15, minus 12. Okay, I will get 5.5 some 5.539. So I will write 542. Is it right value? Please cross check. Is I written right value or wrong? Okay. Similarly, go to 35 degrees Celsius temperature row. And then the all values HF, HFG, HG, SF, SFG, SG. So I have noted down the values now. So I will write directly and you cross check. So what we need to do is take the value of HF at 34 degrees Celsius and HF at 36 degrees Celsius and take the average of these two. You will get for 35. So I will write 346.9. Is it right or value? Wrong value? Please cross check. 123.5, 1470.3. Here values 1.28, 3.726, 4.926. These are the values. Correct? Okay. Later you can cross check. Next form. I will write the formulas. What is the next step we need to do? Once you note down the values, what is the next step? Fifth, sixth step, formulas. I will write the formulas for all the unknowns. The first unknown is mass flow rate. I will write the formula for mass flow rate. It is very easy. It looks a little bit complicated, but it is easy. So formula for mass flow rate is step number 2. Mass flow rate. We need to find out. Formula is very simple. Refrigerating capacity is equal to mass flow rate. Mass flow rate multiplied by refrigerating effect. Both are not same. This is RC. RC stands for refrigerating capacity. This is RE. RE stands for refrigerating effect. This RC value is given in the statement, that is tons of refrigeration. Okay, a tons of refrigeration. 10 is missing, typo error. Write down the value 10. A ton of ammonia. 10 tons of ammonia. Okay, so 10 tons. 1 ton is equal to how much? Any idea? 1 ton of refrigeration is equal to 210 kilojoule per minute. But how much he has given in the numerical? 10 ton of refrigeration. So 10 ton means how much? That you consider as refrigerating effect. So refrigerating capacity. The refrigerating capacity I will get 2100. Correct? 10 into 210. Right or wrong? 2100. Keep in mind unit is in kilojoule per minute. Is equal to mass flow rate. I don't know. Write down the values as it is. Mass flow rate. What is refrigerating effect? Refrigerating effect is related to which component? Evaporator, condenser, compressor, or expansion valve. I have written in the simple sketch here. Refrigerating effect is related to evaporator. So refrigerating effect is equal to H1 minus H5, because this is the starting point, okay, and this is end point. So final point minus initial point, that is refrigerating effect. Dear students, instead of 5, I need to write 4, because H4 is equal to H5. Why it is H4 is equal to H5? Could you tell me anybody? Because 4 to 5 is a throttling process. Throttling. Yes, H1 minus H4. Okay. I will write H1 minus H4 directly. Same formula I will write. Let me give some time because word is not responding. Okay. Okay. Dear students, how to calculate H1 now? I will write here H1 minus H4. Same TS diagram I will draw here, because each and every time we are going to the first phase, then it will create disturbance. Point number 1 is here, point number 2 is here, draw a vertical line. This is cycle. Okay. 1 to 2. I need H1. I need H4. This is point number 3. This is point number 5. Dear students, look at the screen now. Very important steps now onwards. H1 is on dry line. So enthalpy of any refrigerant will be categorized as HF, HFG, and HG. HG is for dry, HF is for liquid, HFG is for wet. This is for dry, this is for wet, this is for liquid condition. Or sometimes some books they will use this as wet condition. This is mixture they will use. Mixture is also correct. A mixture of both dry and liquid is wet. It is wet mixture. Keep in mind. Now, point number 1. Out of these 3, which value will you refer? Will you write HF1, HFG1, or HG? Out of these 3 enthalpy, at point number 1, which value will take? HG value? HG. Very good. Because point number 1 is on dry line. This is dry condition. So directly you write H1 is equal to Hg. It is related to which temperature? Minus 15 or 35? Point number 1 is related to which temperature? This is 35. This is 15.
Minus 15.
Yes, H1 is equal to Hg at minus 15 degrees Celsius. So go to the table. Where is the table? Yes, here. Minus 15 is here. Minus 15. Hg is here. So this value you will consider as H1. I hope you understand. If you have any doubts, please ask me. I will explain once again, no issues. H1 is equal to, I will write as 1424.9, because someone has told these values and I have written in this table, same value, 1425, sorry, 25.7. 425.9 is almost 25, but anyway, I will write 25.7. Any doubts in taking the value of H1? If you do not have any doubts, please tell me no doubts. I will be happy. Any doubts in writing the value of H1? Have you
No,
got
No,
this
sir.
sir.
H1 value? Okay. Answer for question is okay. Okay. Now H4. Okay. Now someone will help me to write H4. How will you write H4? H4 is equal to what? Again, point number 4. Where is the point number 4? Here. So point number 4, whether it is on wet line or dry line. Wet line, but liquid line. Okay, do not get confused.
Liquid.
Some liquid or wet. Okay. Point number 4 is here. So when point number 4 is here, out of these three, which enthalpy will you take?
HF.
HF. Simple. Okay. Write down H4 is equal to HF. At what temperature?
35 D.
Very good. At 35 degrees Celsius. So how much is the value of H4 now? So you tell me the values. So 35 degrees is the second row, and HF you are taken. So 346.9. So that value right here, 346.9. So go to equation number 1. Let us assume this is equation number 1. From this equation, this is equation number 1. From equation number 1, substitute all the values. So 2100 is equal to mass flow rate, we don't know, write down as it is. H1 is how much? H1 is 1425.7 minus H4 is 346. Okay, all values are in kilo. Okay, all enthalpies what you have taken from the thermodynamic data handbook are in kilo, and the left hand side 2100 is in kilo. So no need of conversion. Otherwise, you have to convert to kilojoule to joule by multiplying 10 to the power of 3 here, 10 to the power of 3 here, 10 to the power of 3 here. For each values, you have to multiply with 10 power of 3. So calculate mass flow rate.
1.9466.
1.946 kg. My God, what happened? Okay, kg per minute. Why kg per minute? Because on the left hand side value, this value is in kilojoule per minute. So it will be kg per minute. Have understood how to calculate the mass flow rate?
Yes, sir.
Yes, ma'am. Go to next step number 3. Next step. What is the second unknown here as a COP? So we'll write the formula for COP in the next step. Step number 3. COP is equal to, I hope you remember the formula for calculating COP. COP is performance of refrigerator, that is coefficient of performance. Refrigerating effect divided by work done. Refrigerating effect divided by work done. So now you have to write refrigerating effect in terms of enthalpy, work done also in terms of enthalpy. So refrigerating effect already you have written in the previous steps. Refrigerating effect is H1 minus H4. This is a refrigerating effect. Understood? Oh my God. H1 minus H4 is refrigerating effect. Here it is there. Please refer this H1 minus H4. Same I will write in the step number 3 also. H1 minus H4. Work done. Work done is related to which component? Compressor or evaporator or condenser? 1 to 2 is work done, it is related to compressor. So here which enthalpy is more? H2 is more. So write H2 minus H1. Remember this formula. H2 minus H1 is for work done. Work done is related to compressor. Work done on the compressor, that is H2 minus H1. H1 already you have calculated, no doubt about it. H4 also you have calculated, no doubt about it. Now you have to calculate H2. This is an important step. Okay. H2 is in this point here, superheated region. Okay. Now, dear students, point number 2, whether it is related to HF, HFG, or HG, or not related to these three. Am I audible?
HG, sir.
No. HG is here. This is HG. Any point which lies on this line, it is HG. But point number 2 is not on this line. Or it is not related to any three. I am giving 4 options, whether it is related to HF, HFG, HG, or
Not
not
related,
related.
sir.
Not related. Very good. It is not related anyway. Okay. So it is related to what point? Again, question arises in our mind. It is related to what point? Which point? And dear students, to calculate H2, please remember this hint. From here to here is HF, because point number 4 you have taken HF. Okay. Point number 3 is Hg, already have taken. H3 is equal to Hg. I have not taken, but point 1, point 3, both are on the dry line. So any value if you take on this dry line, it is Hg. Okay, and H1 also Hg. Not same, values are not same, but it is on the dry line. Okay, from here to here it is Hg. But point number 2 is again on the right hand side of this. So H2 is equal to this value. From here to here is H2. Correct? This is H2. So from here to here is H2, means I will add this Hg plus this value, this distance. From here to here is Hg. For 2 Hg, I will add this value. But I don't know this value, how to calculate this distance value, this enthalpy value. So there is one simple formula for this. Simple formula. I will write here H2 is equal to H3 plus this distance value I need to add, enthalpy related to this. So what we need to do is remember this formula. Always you remember this formula. This is equal to change in entropy values. Okay, change in entropy. Let me write entropy value. Okay, so that you will not become confused. Okay, here H2 is here. H2 is equal to H3 plus, remember this formula, my dear friends, Cp T2 minus T3 dash. I will explain you, don't worry, I will explain you. First, I will write in general. Okay, don't deviate from this screen. Okay, because by seeing some faces, you can say that they are not understanding this step. No issues, no issues. H2 is this form here. Again, what is not responding? Okay, fine. H2 is equal to H3. H3 mathematics Hg. Hg, because point number 3 is Hg plus Cp means what? Specific heat. Okay, my dear students, Cp of liquid or vapor will you take in this region? In 2 to 3, whether it's Cp of liquid ammonia or Cp of vapor ammonia in this region. Point number 2 region.
Vapors.
Vapor. So Cp of vapor ammonia. Keep in mind. How much is the value of Cp of vapor ammonia? It is standard value. We need to remember. Remember 2.82. Okay. Anyway, you can take this value also from the data handbook. But you remember, okay, this is a standard value they'll be using in the industry also. Cp of vapor ammonia is 2.82. Cp of steam is 2. That's it. Okay. Cp into, why you have taken T2 minus T3 dash? Okay. T2 minus T3 dash, let me erase this, some terms, and I will explain here. Why I have taken T2 minus T1 dash is, this is important. Here is point number 2. This is point number 3. This is point number 4. This is point number 1. So cycle is going in the anti-clockwise. Point number 2 is more highest, that is greater than point number T3. So I need to add this value. Up to here, you can take from the data handbook. Up to here, it is Hg. I need to add this distance. This distance is difference in temperature value. Difference in temperature, you have to take T2 minus T3 dash. Okay. H2 is unknown. How much is H3? Now, dear students, focus is on calculating H3. Okay, you remember this formula. Instead of getting confusion, how to write value of H2, you remember this formula. Now you tell me how to write H3. H3 is related to HF, Hg or HFG. It is written on the screen. You can see somewhere. H3 is related to Hg. At what temperature? Whether it is related to 35 or minus 15.
35.
Yeah, 35 degrees Celsius. And here it is point number 1 is related to minus 15 degree Celsius. So H3 is equal to Hg at 35 degrees Celsius. Tell me the values. Here is a table. Yeah. So 35 Hg value is 1470.3. That I will write. I will take it as H3. 1470.3 kilojoule per kg. I think you do not have any doubts here. Why I am taking H3 as Hg? Because point number 3 is on dry line. So any values which lies on the dry line is related to Hg. Any value lies on liquid line, it is related to HF. Any value lies between liquid and vapor line, it is HFG. Any value away from the vapor line, means right hand side of the vapor line, this is the formula. Simple. Okay. Next. H3 over time. Now Cp is 2.8, it is given 2.8. Assume it is also standard value. Cp of vapor refrigerant is 2.8 kilojoule per kg Kelvin. Has he given T3 dash, my dear students? T3 dash means T3. It is not dash, T3 only. There is no dash. T3. Has he given T3 temperature, my dear students?
35 degrees.
Very good. T5 is 35. Simple. How much is T1 temperature? Because if anybody asks you to calculate T1 temperature, is how much is T1?
Minus 15.
Minus 15. Correct. How much is T5?
Minus 15.
Correct. 5 to 1 is constant temperature. 3 to 4 is also constant temperature. So T3 is given. T3 is how much? 308 Kelvin. So using this formula, Again, unknown is T2. You don't know T2 to calculate H2. Okay. So what we need to do is one hint he has given in the given data. One hint it is given. Indirectly, it is given as hint. Isentropic compression. So isentropic compression means entropy remains constant during compression process. During compression process, entropy remains constant. Compression is 1 to 2. So during 1 to 2, isentropic compression, that is entropy is constant. So I can write entropy constant is S1 is equal to S2. S1 is point number 1, S2 is point number 2. Okay, now this is in general. Dear students, now you write S1 is related to SF, SFG or SG. You apply the same concept. Whatever the concept you applied for enthalpy, you can apply same concept for entropy also. At point number 1, whether SF, SFG or SG.
SG.
SG, very good. Now I will write S1 is equal to SG. At what temperature? Temperature is what? At point number 1,
-15.
-15. So SG at -15 degrees Celsius. How much is the value of SG at -15 degrees Celsius? There is a table of each and every time you are moving up and down.
5.542.
Yes, here is a value. Very good. 5.542. That value I will write. 5.542. Okay, my dear students, S2 is related to SF or SFG or SG or not related to these three?
Not related.
Not related, because point number 2 is not on dry line, not on liquid line, or not in between these two. It is away from the dry line, so it is superheated. So how to calculate S2? Again, you remember one simple formula. One general formula you remember. Anyway, these numericals will help you in the next semester also. So S2 is equal to S3. Same formula I will write, not a different formula, same formula. Whatever the enthalpy formula I have written, same, only slight will change. Slightly will change. S3 plus Cp ln of T2 by T3. T2 by T3. You can ask a question, sir, why you have taken ln here? Why you have taken difference in temperature here? Dear student, this formula is Q value. Heat supplied, Q. Already you know one formula we have discussed in the module number 3. Entropy, ds is equal to dq by T. Okay, change in entropy is related to Q by T. You write the formula of say Cp delta T divided by T. Once you do the integration, you will get ln T, ln of T. So ln of difference in temperature between T2 to T3. Understood? So that is the reason we have written ln 2 by 3. So if you are confusing that, oh, tumba kashta ide andre, you would by heart it. By heart mark. Okay. S2 I need to calculate, because in the S2 temperature is there here. I need T2. This T2 I need to substitute in this formula. In this formula to calculate H2. So I need this T2 to calculate this H2. So where that T2 is available? T2 is available in this formula. So using this formula, I can calculate T2. So dear students, what is the value of H3? S3, you tell me. S3, look at the sketch. Do not worry, it will take too much of time, but once you understand, all numericals will become easy. Here is a diagram of a simple sketch. Now my question is, S3 is SF, SFG or SG? Point number 3.
Yes.
SG. Very good. Point number 3 is SG. So SG at
35.
what temperature? At 35. Very good. Very good. Very good. So here S3 is equal to SG at 35 degrees Celsius. How much you value told?
4.926.
4.926 kilojoule per kg Kelvin. Now S2, S3, everything you know, equate in this equation. So here, let me substitute all the values at a time. Instead of writing 2 to 3 times, I will write at a time. So S1 is 5.542. 5.542. S1 is equal to, right, is equal to, S2 is, write down this equation directly. S3 plus Cp ln of T2 by T3. So 5.542 is equal to, S3 is 4.926, Cp value is 2.8, it is standard value, ln of T2, I don't know. How much is a T3? Again, I have to go back to the sketch. Yes, T3 is 35 degrees Celsius, because point number 3, 35. So you have to convert into Kelvin. Very good. How much? 308.
8.
Yeah, here also it is written. 308. So that is right on here. And tell me the value of T2. And dear students, common sense question, whether T2 should be more than T3 or less than T3. Refer the sketch.
More
T3,
than.
yes, it should be more than T3. Due to some calculator mistake, if you got the wrong value, you cross-check the answers. You have done something wrong. T2 is ahead of 3. It is greater than T3. Okay, how much you will get now?
383.79.
1 minute, ma'am. I will write here 383.79. 383.79 Kelvin. So this T2 temperature, you substitute in enthalpy equation H2. Where is it H2? There देखो, इधर मिल गया. In this equation, you substitute. Take this is equation number, some equation you refer some 2, 3 equation and that. Okay, equation number 2, equation number 3, like that. For your reference purpose. For your reference. So H2 is equal to, someone will help me to write the formula. H2 is equal to H3 plus Cp ln of T2 minus T3. And dear students, sorry, LAN is not there. Very good. Yeah, because hint, you remember hint. When you are taking entropy, LAN will come into the picture. When you are taking enthalpy, no LAN will come to the picture. That is a hint. Remember. And one more hint. Always you refer highest temperature minus lowest temperature. Do not take T3 minus T2. Okay, 2, 3, final is 3, 3, 2 minus 2, highest temperature minus lowest temperature. Otherwise, you will get negative value. Negative will not come into picture here. Negative ಬರೋದಿಲ್ಲ. If negative ಬಂದಿದ್ರೆ ಹೊಗೆ ಹಾಕ್ಸ್ಕೊಂಡು ಹೋಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Okay, so substitute all the values and tell me the H2. Here I should not give gap. Very good, they have identified T2 minus T3. H2 is on. How much is the value of H3? Where we have written H3? Where is that H3? H3. Here is 1470.3. 1470.3 plus 2.8. T2 383.79. Again T3 308. So H2 is equal to how much? Tell me the values. I am waiting for you. ನೀವು ಹಂಗೆ ಕುತ್ಕೊಂಡು ನಾವು ಹಂಗೆ ಕುತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಮತ್ತೆ
168.5
168
2
2.
0.51.
Okay. So this is H2. So where we need to substitute all the values? Where? In which formula? What is the unknown?
COP.
Second unknown. COP. Okay. COP is equal to, instead of going to the, I will write the values directly here because I know the formula. I think you also know the formula. COP is equal to refrigerating effect divided by work done. Refrigerating effect is related to condenser. So H1 minus H4 or H5. You can write the H1 minus H4 also. That work done is related to H2 minus H1. So substitute all the formulas, all the values. And one hint I gave you. How much will be the value of COP? Less than 1, greater than 1? हमको क्या पता सर? Value of COP should be less than 1 or greater than 1? Value of efficiency will be less than 1 or greater than 1?
Greater than 1.
Efficiency. Efficiency is less than 1. COP should be greater than 1.
Greater than.
Opposite to each other. Yes, correct. Maybe you are told for COP. I have misunderstood. Okay, COP is equal to, should be greater than 1. If you got less than 1, somewhere 0.5, 0.4, that
4.2.
is wrong. How much value?
4.2.
4.2. Okay. Sir has told you that COP should be greater than 1. Do not write directly in the exam. Something 2, 3 and everybody. Somewhere. I give a hint, right? In the class, you apply that hint. When you need to apply that hint, you remember it very well. COP is 4.2. This is second unknown. Next, what is the third unknown here as power? Power is again very simple formula. Power is equal to mass flow rate into work done. I will write the last step here. Step number 4 or 5. Don't know, sir, how many steps you have written. Step number 3 is over. Now we are writing step number 4. Very simple. Step number 4. Power is equal to work done into mass flow rate. What is work done? Work done is H2 minus H1. And what is mass flow rate? How much you got mass flow rate?
1.946.
1.946. My dear students, we have to be careful when you are multiplying these two. The values look same, but you will get the different answers. What is the different answer? Is work done is difference between these two. What is the unit? Kilojoule per kg. What is the mass flow rate unit? Kg per minute. Once you multiply these two, you should get in kilojoule per minute. But it is not power. You have to convert into kilojoule per second. Okay, substitute the value of H2 and H1. I will tell you how to do it. H2 is somewhere 1682.5. 1682.5. H1 is H1, 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 H1. Go to table. H1 is 1425.7. Here is there. 1425.7. Into not minus 1.94. So multiply these two.
499.75.
499. One more 9.
No, sir. 0.75.
0.75 kilojoule per minute. How to convert to kilojoule per second? Multiply by 60 or divided by 60 for this?
Divide by 60.
Yes, just divide by 60. Divided by 60. I will take in different color. If you write in kilojoule per minute, sometimes it is right. Sometimes some people will say that it should be in kilowatt. Kilojoule per second is kilowatt. So when you divided by kilojoule per minute, it will be in kilojoule per second. That is kilowatt. How much will you get? 500 divided by 60. 500 divided by 60 is almost
8.32.
something. 8.
8.3 kilo.
Yes, 8.3 kilojoule per second is the right answer. Our right power is equal to 8.33 kilowatt. So this will be for 12 marks or sometimes 10 marks. Dear students, problems looks complicated because this is the first or second time you are practicing. Once you practice 2 or 3 times, you'll understand it and you'll solve it easily. Any doubts are there? You can ask me.